Good morning friends. Today we will have a tutorial exercise on some of the topics that we have covered so far. I will take up a few examples and discuss. There is a problem. First example is a very simple one. You have a bridged capacitive circuit. The values are 2 farads, 1 farad, 4 farads and 1 farad. What will be the equivalent capacitances C1, C2 and C3. Okay. Now, in this case, as you know, a capacitor is having an impedance. If you talk in terms of sinusoids, it will be 1 by omega c, it is J here. If you talk in Laplace domain, it will be 1 by SC. That means the impedance is inversely proportional to C. So, I can take these capacitances to be equivalent impedances or even resistances with the values which will be just inverse of these, something like half ohms, 1/4 ohm, 1 ohm and 1 ohm. I can replace it by an equivalent impedance circuit. Now, after this we can get an equivalent one by a star delta conversion. So, if this is a delta, then I can have a star like this. So, these 3 nodes are these 3. So, what will be the value of this? 1 into half divided by 1 plus half plus 1. So, 1 into half divided by 2 and a half. So, that gives me 1 by 5. 1 by 5. Similarly, this one will be 1 into 1 by 2 and a half. So, 2 by 5 and similarly this is 1 into 1 and this one will be again 1 and a half. So, this one will be 1 by 5, this is 1 by 4. So, you get 1 by 5, 2 by 5 and 1 by 5 plus 1 by 4, 9 by 20. So, take the inverse of these, that will give you the equivalent capacitance 5 farads, 2.5 farads and 20 by 9 farads. Okay. So, these are the 3 equivalent capacitances. Okay. It is so simple. Next, we are given a problem on transmission parameters of 2 cascaded sets. The problem is a very simple one. This is ZA1, ZB1, ZC1 cascaded with ZA2, ZB2 and ZC2. What will be the total ABCD parameters of the total combination. What will be the ABCD parameter of this total combination? The values given are ZA1 equal to 50 ohms, ZB1 equal to 0, ZC1 is equal to 300 ohms. ZA2, ZB2, ZA2 is 0, ZB2 is 50 ohms, and ZC2 is given as 600 ohms. What will be the ABCD parameters? Let us draw this network first. This is 50 ohms, this is 300, this is 0, this is 0, this is 600, and this is 50. You see, the network is very simple, it is a pi network. If I combine them, it will be 50 ohms, 600 and 300 in parallel, that gives me 200 ohms and 50 ohms. So, ABCD parameters, if you remember, V1 I1 we are writing in terms of ABCD as V2 I2. So, A is V1 by V2 when I2 is 0. Similarly, C is I1 by V2 when I2 is 0. B is minus B is V1 by I2 when V2 is 0, that is under short circuit condition, and similarly D is minus D is I1 by I2 when V2 is 0. So, from this diagram it is very simple, V1 by V2, this is 50 plus 200 and this is 200. So, 250 by 200, A is 250 by 200, that gives me 1.25. Similarly, B you can find out V1 by I2 when this is shorted. When this is shorted, you apply a voltage V here. What is the current that is flowing through this? So, B comes out to be 112.5 ohms, C comes out to be 5 into 10 to the power minus 3, and D is once again 1.25. These are very simple relationships, all of you can determine this. Next, we have a question. Determine for a network like this, coupled circuit having 3 coils wound on this steel structure. One dashed, you are sending a current I1. This is 2 dashed shorted through a resistance R2, and similarly you are having 3 dashed, there is a resistance here R3. The question is, there are 4 statements given. which one is correct. I2, when current is flowing through this winding 1 dashed in this direction I1, then the currents through R2 and R3 will be, one possibility is I2 will be 2 to 2 dashed externally, 2 to 2 dashed, and I3 will be 3 to 3 dashed, 3 to 3 dashed. Okay. B, I2 is 2 dashed to 2 and I3 is 3 to 3 dashed. C, I2 is 2 dash to 2 and I3 is 3 dash to 3. The fourth possibility is I2 is 2 to 2 dashed and I3 is 3 dash to 3. Okay. So, you have to see whenever there is a current flowing through I1, what is the sense of the flux flowing through this. Suppose you take the current in this direction, all right, it is coming out like this. So, what will be the north pole? North pole will be in this coil, it will be in this direction, and here it is coming out. So, this is south. So, flux will be flowing like this, okay, like this. So, in R2, suppose the current is from 2 to 2 dashed, this is kept open, this is kept open, 2 to 2 dashed, then which direction this current will send the flux? If you look at it, 2 to 2 dashed, that is current is going like this, then current is flowing in this direction, okay, from bottom to top, it is in this direction. That means, this will be a north pole, this will be a south pole. When it is going like this, it is north pole. So, that means, it will try to send the flux like this and like this. So, it will be adding this flux, that is not possible. If I excite this now, if I excite this now, and if the current flows like this, then this will try to add to the flux that is already being established by this. Okay. So, that goes against the very basic principle of conservation of energy. So, this will be trying to, if the current flows in this direction, this will try to oppose the flux. So, this one will try to, if a current I1 flows through this, it will try to flow, it will try to send a flux like this, then this current has to be in this direction. So, it will be 2 dashed to 2. So, 2 dashed to 2, there are two possibilities. What will be the current through this? Similarly, if you go through the same argument here, if a current flows like this, what will be the direction of flux? You will find if it is 3 to 3 dashed, 3 to 3 dashed, okay, then the flux will be opposing the flux that is being established by I1. Okay. So, this will be the correct direction of the currents. That is, this current will be from 2 dash to 2, this current will be 3 to 3 dashed. So, this is the correct answer. Next, we take up another example. Write the expressions for the functions and so on. It is a periodic function 0, 10, 20, 30 and so on. This is 100, it is a rectified sine wave. What will be the expression for the current Ft, current or voltage, whatever you write. In terms of continuous functions, regular functions, and what will be the corresponding Laplace transform. Now, f t, if I take only the first period, it is a part of 100 sine 2 pi by t, where t is basically, this is the period 20, okay. It is this period. If I write like this, then it will represent a function which continues. If I add another function to that, I call this part as only one period. Then if I add another sinusoid which is delayed by 10 seconds, 100 sine 2 pi by 20 into t minus 10 seconds into u t minus 10, then this plus this will be giving me a net function of, see, this is the first part plus a function that I am adding from here. So, this plus this will give me, this will get cancelled with this, the first wave, okay. It will keep on cancelling henceforth after 10 seconds. So, if I add this with this is a delayed function represented like this, I will get this one, which I am calling as f1t. Okay. So, somebody may write f_t as f1t plus kt, where t is 10 seconds, and write like this summation, it will represent this function, okay, where k is any positive integer. So, it will represent this function. Of course, into u t minus k t will be the correct representation. So, this is f t. Now, 2 pi by 20 can be written as pi by 10. What will be the Laplace transform of this then? Let us again start from the beginning. Laplace transform of this function, if I call it f1s, so it will be f1s plus Laplace transform of this shifted by 10 seconds, f1s into e to the power minus 10s plus f1s into e to the power minus 20s, and so on, which means f1s into 1 by 1 minus e to the power minus 10s. And what is f1s? f1s will be Laplace transform of this, which is 100 into sine 2 pi by 20, means pi by 10 divided by s squared plus pi by 10 whole squared. This is the Laplace transform of this part, and for this part the same thing shifted by 10 seconds. So, it will be this plus this into e to the power minus 10 minus 10s. So, combining the two, I will get, so this is f1s. So, substitute here, so that gives me 100 into pi by 10, that gives me 10 pi divided by s squared plus pi by 10 squared into 1 plus e to the power minus 10s by 1 minus e to the power minus 10s. somebody may write this as cot hyperbolic 5s e to the power minus 5s if I multiply. So, cot hyperbolic 5s. Okay. So, this will be the Laplace transform. Similarly, there is another function what will be the expression for this type of periodic function. It is pretty simple 0, this is 5, 2, 4, 6, 8, 10 and so on, this is minus 5. Obviously, the first block can be written as 5 into ut, and then at 2 seconds I apply a negative step at ut minus 2. So, that gives me the first block. Again at 4 it is negative. So, minus ut minus 4, and at 6 I apply ut minus 6, a positive step, and that completes one period up to 8 seconds, and then it keeps on repeating. So, show one period, if I show one period and then show it as a repetition of the same function, this will be written as 5. I can write this as summation ut minus 2, okay, ut, so plus after 8 seconds again it is plus ut, okay. So, ut plus k a 8 minus u t minus 2 minus k 8, okay, minus u t minus 4 minus k 8 plus u t minus 6 minus k 8, where k varies from 0 to infinity. This will be the representation of the periodic function. What will be the Laplace transform of this? It is 5 into, you take just one period and that keeps on repeating. So, for one period Fs will be, for one period it is 5 into 1 by s into 1 minus e to the power minus 2s minus e to the power minus 4s plus e to the power minus 6s, this whole thing into 1 by, it is repeated 1 minus e to the power minus 8s, is it not? This is something like our earlier f1s and multiplied by this, that will give you total fs. So, 5 by s, 1 minus e to the power minus 2s can be taken common. So, in bracket we get 1 minus e to the power minus 4s, that is equal to 5 by s to 1 minus e to the power minus 2s, e to the power minus 4s and 1 minus e to the power minus 8s, there is a common factor. So, that gives me 1 plus e to the power minus 4s. So, this will be the Laplace transform of this function. Okay. Next, we have a question on Laplace transform again. Determine the initial and final values of the function whose Laplace transform is given as s plus 4 into s plus 70 divided by s plus 1 into s plus 5 into 2s plus 7. Obviously, f0 we compute as limit s tending to infinity s into fs. So, if I multiply by s and then make s tending to infinity, only the highest power of s has to be computed. So, limit s tending to infinity, if I leave only the highest powers, it will be s cubed after multiplying by s into s into s divided by s into 2s. So, that gives me half. Similarly, f at infinity will be limit s tending to 0 s f s. If I multiply by s and then put s equal to 0, all these terms will give me 4, 71, 5, 7, but this s will give me 0. So, this is 0. Next example, the step response of a network is 1 plus e to the power minus t sin 10 t into ut. Find the steady state response. The steady state response when the input is 10 sin 10 t. That means, if I have instead of e to the power minus t, that is a decaying sinusoid, if I have a steady sinusoid, what will be the response? Let us see. Let us determine the transfer function. The Laplace transform of the output is for the step input, the step response is 1 by s plus 1 by s plus 1 whole squared plus 10 square, will be 10 by s. Okay. One may write this as s squared plus twice s plus 100. So, s squared plus 2s plus 10s, so 12s plus 100 divided by s squared plus 2s plus 101. Okay, s squared plus 2s plus 1. So, this is also 101, all right, multiplied by s. So, the transfer function can be written as output by input. Input is 1 by s. So, if I divide this by 1 by s, that comes out to be s squared plus 12s plus 101 divided by s squared plus 2s plus 101. Okay. This is a step response. So, if I divide the response by the input, we want to find out the input was step input. So, Laplace transform is 1 by s. So, after dividing by 1 by s, we get this. Now, we want to determine the steady state response due to a sinusoidal input. So, for a sinusoidal input, we straight away write s equal to j omega. Omega here is 10. So, if I substitute here, therefore, g I call it gs. So, g j 10 will be minus 100 minus omega squared. So, minus 100 plus 12 into j 10 plus 101 divided by minus 100 plus 2 into j 10 plus 101. That gives me 1 plus 20 j divided by 1 plus sorry 120j divided by 1 plus 20j. 1 is very small compared to 120. So, this is approximately 120 and an angle very close to 90 degree. Similarly, 20 plus 1 plus 20j, that will also give me a magnitude close to 20 and an angle very close to 90. So, both these angles almost 90 degrees will give me approximately 0 angle. Magnitude is 6. So, what will be the output? Steady state output? It will be input multiplied by this 6 angle 0, 10 sin 10 t. This is not the correct way of writing, I just wanted to explain. So, the magnitude gets multiplied by 6, angle gets shifted by this angle theta, which is 0 approximately. So, it will be 60 sin 10 t. This will be the response, steady state response. Okay. Next, we have another example. You are having okay, let me use this space. You are given a simple circuit you are asked to calculate IS. This is a DC source IS, and then the voltages across R and C at initial and final condition. All right, initial and final values of the voltages across the 3 elements. Okay, and then what will be the critical value of R? Okay, for critical damping. What will be the value of R for critical damping? So, let us compute the impedance. This can be replaced by E by S SL. I should write a general impedance R 1 by SC, assuming no initial charge is residing here, no initial current was there. So, IS will be E by S divided by the total impedance SL plus combination of this will be R by RCS plus 1. So, if I combine, it will be E into RCS plus 1 divided by RCL square plus SL plus R, okay, into S. This will be the expression for IS. What will be the voltage across the inductor? Voltage across the inductor, it will be SL times IS, is it not? So, S will get cancelled. So, it will be E into L into RCS plus 1 divided by RCL squared plus SL plus R. Now, if I want to calculate the steady state value, that is VL at infinity, then I should calculate S VLS and then put S tending to 0. So, if I multiply by S this quantity and put S equal to 0, the whole thing will become 0. If I want to compute VL at 0, then I will compute S times VLS at S tending to infinity. And how much is that? If I multiply by S, if I multiply this by S and then make S tending to infinity, highest power of S will have to be taken. So, it will be S squared into R L C E, and here it is R L C S squared. So, these terms will get cancelled, you will be getting only E. Basically, at start the entire voltage appears across the inductor. Obviously, what will be the voltage across this combination? Mind you, voltage across the resistance and voltage across the capacitance will be same. So, you need not find out these values separately. The voltage across the resistance, when this is having maximum value in the initial condition, this will be 0. At t equal to 0, this is equal to E. So, this will be 0. At t equal to infinity, this is 0. So, this will be E. So, VR, which is equal to Vc, will be equal to 0 at t equal to 0, Vr equal to Vc equal to E at t equal to infinity. Okay. For critical damping, this quadratic, you have got R L C S squared plus S L plus R. So, equate B square is equal to 4 AC. So, L squared is equal to 4 into R into R L C. So, that gives me R squared equal to L by C into 4, okay, or R critical is 1 by 2 root L by C. So, this will be the condition for critical damping. Next, we have another problem. Network is given by Ys equal to S plus 1 into S plus 5 divided by S into S plus 4 into S plus 6. You are asked to show the unknown arms of this network in this form. What will be these unknown arms? X1, X2 and X3. It continues. This is given as R1, R2, R3. What will be the nature and the values of these X1, X2 and X3? Obviously, this is given in a ladder form. Okay. So, we try to find out the ladder structure. So, this is S squared plus 6S plus 5 divided by S cubed plus 4 plus 6, 10 S squared plus 24 S. Okay. This is Ys. So, correspondingly Zs, you see the first element, if it is present, then it has to start with a Zs, which will be S cubed plus 10 S squared plus 24 S divided by S squared plus 6S plus 5. Okay. Zs of this form, is it RL or RC network? Obviously, Ys having a pole closest to the origin, closest to the imaginary axis, is giving me RL. It is an RL network. So, this will be an inductance, resistance, inductance, resistance and so on. So, by continued division, S squared plus 6S plus 5, I will write only the coefficients 1, 10, 24. This will be S 1, 6, 5, 4 and 19. 1, 6, 5. So, 1 by 4, 1, 19 by 4. So, this gives me 5 by 4 and 5, this is 4 and 19, 5 by 4. So, that gives me 16 by 5, okay, 16 by 5, 4 and 16, then 3, 5 by 4, 5. So, this will be giving me 12 by 5. Is that all right? Is it 12 by 5? No. 3 into 5 by 12. 3 5s are 15 by 12, okay, 5 by 4, then 5, 3, 3 by 5. So, what we get, this is S, this is S. What you get is 1 Henry, then this is an admittance of 4 ohms, then this is 16 by 5 Henry, and then 5 by 12, so 12 by 5 ohms, and then 3 by 5 Henry. So, the unknown values are x1 is 1 Henry, x2 is 16 by 5, x3 is 3 by 5. Okay. The same function you are also asked to evaluate the impedances x1, once again nature and the values of x1, x2, x3, okay, R1, R2, R3, and this is R4. What will be the values of x1, x2, x3? So, obviously, this is a Foster 1 realization. So, ZS, start with ZS. So, ZS is S into S plus 4 into S plus 6 by S plus 1 into S plus 5. So, I break it up into K1 into S, since this is of higher degree, plus K2 by S plus 1. Should I have K2 by S plus 1 or K2 into S by S plus 1? I have already identified this is an RL network. So, for an RL network in Foster 1 synthesis, remember the Z synthesis will require K2 S by S plus 1. If you do not take K2 into S, you are landing up into trouble. We saw earlier also, you will get negative values of K2, K3, etc. Some of them may come out to be negative. So, this one K1 will be, if I divide by S, make S tending to infinity, this becomes 1. K2 divide by S, multiply by S plus 1, make S plus 1 equal to 0. So, it is 3 into 5 by 4, 15 by 4. S plus 5, so this will be minus 1 plus 1 and 4, so 1 by 4. So, these values are, this is 1, okay. So, if it is like this, obviously you do not require all of them, there may be, sorry, I forgot to mention here, this is x1, this is x2, x3. This will not come because the order is only this much. So, x1, so K1 represents x1, Okay. This is S plus K2 is 15 by 4 by S plus 1 S plus 1 by 4 S by S plus 5. So, for this one, this is 1 Henry, x1 is 1 Henry. From here you can see, if I make S tending to 0, S tending to 0, this is 15 by 4. So, x2 is 15 by 4 Henry, and x3, if I make S tending to infinity, S tending to 0, is this is 1 by 4 Henry. Okay. So, these are the three values, 1, 15 by 4 and 1 by 4. S by 4 into 5, it should be 20, sorry, 4 into 5. When I make S tending to 0, it is S by 4 into 5. So, 1 by 20 Henry. Next example. If you have a little more time, determine the value of B, C and A for the impedance function ZS equal to 5 into S squared plus B by S squared plus C, where this network has been partly realized as A Henry and half a farad and 1 Henry. That means a network has been given, this is a structure, two values are known, this is not yet known, but its transfer function is of this form. What will be B, C and A? This is a problem. So, let us see these two combinations, 1 Henry and half a farad, will give me 1 Henry. I can write this as AS plus, this is S into 2 by S divided by S plus 2 by S. So, that gives me AS plus 2S by S squared plus 2. Correct me if I am wrong. Is that all right? Now, this is equal to this. So, C has to be equal to 2. Okay. C has to be equal to 2. If I add these, S squared plus 2 into AS plus 2S, that gives me S cubed plus twice A plus 2 into S, and that is equal to 5 S cubed plus 5 S cubed plus 5 BS. So, here A S cubed, sorry, A is equal to 5, and if I put A equal to 5, 5 into 2, 10 plus 2, 12 is equal to 5B. Therefore, B is equal to 12 by 5. Okay. This is a very simple example. Well, before we take up any other problem, I think we will stop here today. We will continue in the next class because there is not much of time left. Okay. Good morning, friends. Today we will have another tutorial session. The first question is, determine the Laplace inverse of factorial n divided by s into s plus 1 into s plus 2 up to s plus n. Okay. So, easiest method is to find out the partial fractions. I will write a0, a1, a2 by s plus 2 and so on, ak by s plus k general term. Okay. So, how much will be a0? A0 multiplied by s, this fs, make s tending to 0. So, that gives me factorial n divided by 1, 2, 3, 4 up to n, that is equal to 1. A1 multiplied by s plus 1, make s plus 1 equal to 0. So, what do I get? A1 as 1 into 1, 2, 3, 4 up to n minus 1. So, that gives me n with a negative sign, because the first one will be minus 1. A2 will be factorial n divided by multiply by s plus 2, then make s plus 2 equal to 0. So, it will be minus 2 minus 1, minus 2 minus 1, then 1, 2, 3 up to n minus 2, and that will give me plus n into, see, I get minus 1 minus 2 n minus 2. So, factorial n divided by factorial n minus 2 into factorial 2. A3, and what is this? You can identify this as NC2. A3 similarly will be factorial n divided by minus 3, minus 2, minus 1, then 1, 2, 3 up to n minus 3. So, I get minus 1 into factorial n by n minus 3 factorial into factorial 3, that is NC3 with a minus 1. Network function Ys is shown like this. For Ys, some Ys, this is minus 30 dB, these are all 20 dB per decade slopes. This is 5, 10, 20, 40. This is 0.2. These are not to the scale exactly. This is 0.2 minus 30. What will be the value of Ys? And the next question is it defining a driving point impedance or admittance function? is it a driving point admittance function? If not, justify. If yes, state the reasons and then realize one in Foster 2 form. So, if yes, then realize in Foster 2 form, and if not, justify why it is not a driving point admittance function. Let us write y s V2 by I1 or I1 by V2, I1 by I2 and so on. That means, you may be given the specifications either in terms of Z12, Y12, Y22 and so on, and Z11. So, specifications can be given in terms of Z11, Z12 or Y12, Y22 or V2 by V1 and so on. You have to determine a possible network. So far we have studied the driving point synthesis. Now, we shall be going for 2 port synthesis with transfer impedances. Okay. Some of the basic conditions for these impedance and admittance functions, that is the transfer impedances and transfer admittances, are very interesting. And so, for transfer function also, you will find the numerator and the denominator polynomials ns by ds. They need not have all the properties that were listed in the driving point synthesis, that is, the difference in degree can be more than 1. Difference in degree can be more than 1. Can be, may or may not be, but ds must be a Hurwitz polynomial, roots must be always in the left half plane. So, ds must be Hurwitz. There can be multiple roots, multiple zeros on ns, there can be all possible combinations. So, we shall study in details what are the conditions to be satisfied for 2 port synthesis, what are the conditions for Y11, Y12 or Z11, Z12, this pair of admittance or impedance functions. Thank you very much.